Hi, this is Mr. Marzillier, and we're taking a little bit of a closer view of finding the area of a triangle. Well, the area of a triangle is found by taking the product of the base and the height and then dividing that by 2. So there are a couple of things that you need to understand. You need to first understand the different parts of a triangle, the base and the height, so that you can correctly plug in the values for the formula. And I think it's also important to find out why the area of a triangle is half the base times the height, or base times height divided by 2. Let's take a look at another triangle, a matching triangle. It looks just like the one that we have displayed. If you bring the two of them together, merge them together, you can see that actually a triangle is half the area that of a rectangle. So if we know that the formula, which we learned previously in class, of a rectangle to be length times width, and if we cut that right in half, right on the diagonal here, you can see that if we take half of its area, we're left with that area of a triangle. So instead of using the terms length and width, we use base and height to differentiate between the triangle's dimensions and a rectangle's dimensions. Well, the base is not necessarily always the bottom of the triangle, although for the purposes of this illustration, I put it at the bottom anyway. But you can always identify the base of a triangle and the height of a triangle because you need to look for this little right angle indicator. That indicates that that little chiclet there is a 90-degree angle, or that the height and the base intersect each other at a perpendicular angle. That's 90 degrees. I sometimes will even draw a little arrow here, and that lets me know that I'm actually pointing to the base and to the height segments of that triangle. Now the base is not necessarily the bottom, like I said before, but it's always one of the dimensions that make up the triangle. So it needs to be one of the 3 line segments here that makes it up. And if you know what the base is, then of course the height is the other one. All right. Now no matter which way that I actually rotate this triangle, the height is still the height. So once we establish that, that would still be the height, and this line segment would still be the base. The real indicator is that right angle segment, because what it does is it tells you that you're dealing with base and height here. All right, so once the base, always the base. You can think of it as like a lamp base. If we turned it upside down, the base of that lamp is still the base, even though it's positioned in a different orientation than it was before. So the area of a triangle is found by taking the base and the height and dividing that by 2, the product of that by 2. So let's take a sample, or a look at a sample here so you can get a better idea of how it works. Here's a triangle. This triangle can be a little confusing at first to look at, but as soon as you find that right angle indicator, that's where your eyes need to zoom in first, because that helps you identify the 2 components that you're going to be looking for, base and height. Well, the right angle indicator here lets me know that I'm dealing with an outside line segment. That's going to be our base. And the other segment that I'm dealing with is going to be the height. The base here I've already color-coded for you in green. That's 8. And the height here has not been color-coded. That's going to be 3 meters. There's an extra piece of information that's listed here. Can you figure out which one it is? That's right, it's the 5 meters. Just turns out to be the hypotenuse of this right triangle here, this smaller piece here. But it's actually extra information, and it's not needed. It's sometimes designed to throw off students a little bit so that they plug in the wrong values. But you're not going to fall for that, because you know that the right angle indicator connects both the base and the height at a perpendicular location. So in this case, all we have to do is start plugging in the values, and we always start off solving any of these types of problems because the state test is going to ask you to write down the formula, and when you get to your Regents classes, you're going to need to eventually do that anyway, write down the formula. We always start with the formula first, base times height divided by 2. The next step is to actually plug in the values. So the base we already established to be having a value of 8 meters. The height has a value of 3 meters. And we're going to put those in parentheses because order of operations tells us that we need to perform that operation inside the parentheses first, which means we're going to be multiplying first. So we have 8 times 3 divided by 2. We'll evaluate what 8 times 3 is. That's 24 divided by 2. And then we do our final division, and that gives us a total area of 12 square meters, or meters squared. A quick word about labeling area problems. A lot of students tend to forget the label, or are not sure what to put down as a label, because for area you have to remember we're covering a flat 2-dimensional closed figure with squares. And even though it may not look like 12 perfect squares will fit inside of that triangle, they will. And some of them might have to be cut up to fit into corners. But when we look at all of the squares collectively, It turns out to be 12. The unit is very important, and since we were measuring in meters, our first unit becomes meters. If this was feet, we'd put feet. If it was yards, we'd put yards, and so forth. The exponent 2 stands for the number of dimensions that we dealt with in order to come up with the area. And since area, no matter what shape you're dealing with, deals with length and width, or in this case, base and height, that's 2 dimensions. The superscript 2 here, or the exponent 2, really deals with the 2 dimensions that we're dealing with for the square, which would be length and width. So it's always meters squared. If you prefer, you can actually write it out as meters squared or square meters, your choice. Mathematicians like to do things as quick as possible, so the quickest or shortest way to abbreviate that would be m for meters and the exponent 2 for meters squared. Very important to keep a couple things in mind here as well. Take a look at how I wrote and structured out the formula here. We'll start back from the original part. I wrote down the formula. Everything is in this lockstep fashion, nice and neat, easy to follow. This way, if I make any mistakes, or if anyone's grading my work, they can see very quickly where I went wrong and assign me as many partial credit points as possible, especially if this is a state test. Everything gets plugged in. We take every step-by-step fashion, nice and neat. Everything gets dropped into its location. And our final answer should always be circled. You should put a box around your final answer because you really want to have this stand out from the rest of the problem. This is your final answer. So enjoy taking a look at other area of triangle problems, and I hope this video helped you out a little bit. Good luck.